Good morning, students. Our today's class deal with carbohydrate, their classifications and some of their properties. Carbohydrates are the most abundant biological molecules. They are aldehyde or ketone compounds with multiple hydroxyl groups. They are the compounds made up of carbon, hydrogen and oxygen. They are also called saccharides as the lower member of these are highly sweet to taste. Now based on the chemical composition, the carbohydrates are divided into three types. They are monosaccharide, oligosaccharide and polysaccharides. Monosaccharides are the simplest sugar which cannot be further hydrolyzed. Example, glucose, galactose, etc. Whereas oligosaccharides are those carbohydrates that on hydrolysis yield nearly 2 to 10 monosaccharides. And depending upon the number of hydrolytic products resulted from the oligosaccharides, they are further classified into disaccharide, trisaccharide, tetrasaccharide, etc. And polysaccharides are complex carbohydrates made up of multiple monosaccharides combined with each other. Sometimes these polysaccharides are called glycans because of their subunits, that is monosaccharides are joined together with glycosidic linkages. Now these carbohydrates are widely distributed in nature in plants and animals. The most important carbohydrate found in plant is starch, and they are abundantly seen in roots, tubers, leaves, vegetables and grains. And in animals, they are found in the form of glycogen, and it forms the storage form of carbohydrates in animal and is found abundantly in liver and muscles. So the classification of this carbohydrates are mainly into monosaccharides, oligosaccharides and polysaccharides. Now let us see all this one by one. Monosaccharides. They are the simple type of carbohydrate and they contain only one molecule of sugar. So they cannot be broken into simpler substances by hydrolysis. And some of the examples includes glucose, fructose, etc. They are sweet in taste, they exist in crystalline form and they are soluble in water. Now on the basis of the carbonyl group, monosaccharides may be either aldose, that is carbonyl group is aldehyde, or ketose when the carbonyl group is ketone. And these monosaccharides are further divided on the basis of the number of carbon atom present in them. Now based on the number of carbon atom, they are further classified into triose if they contain 3 carbon atom, tetrose if they contain 4 carbon atom, pentose if they contain 5 carbon atom, hexose if they contain 6 carbon atom, and heptose if they contain 7 carbon atoms. Now, as I had mentioned, monosaccharide exists in two forms, ketose form if they contain keto group and aldose form if they contain aldehyde or CHO group. Now, some of the examples of triose sugars are glyceraldehyde and dihydroxyacetone. Glyceraldehyde is the aldose form of triose sugar and dihydroxyacetone is the keto form of the triose sugar. Then pentose sugar. Pentose sugar example is ribose is the aldose form and ribulose is the keto form. Example of dextrose is erythrose, the aldose form, and erythrulose, the ketose form. Then examples of hexose includes glucose, galactose are the examples of aldoses, whereas fructose is the keto form of the hexose sugar. Heptose. Heptose, they contain 7 carbon atoms. Pseudoheptulose is a good example of heptose sugar. So these are the structural representation or chemical structure of various types of monosaccharides. The second class includes oligosaccharides. Oligosaccharides contain nearly 2 to 10 monosaccharide molecules which are liberated on hydrolysis. And based upon the number of monosaccharides, they are further divided into disaccharide, trisaccharides, tetrasaccharides, etc. Then disaccharides are those carbohydrates which eat two molecules of monosaccharides on hydrolysis. Example, maltose, sucrose, lactose, etc. Maltose. Maltose on hydrolysis eat glucose, two molecules of glucose. So, with the help of enzyme maltase, this maltose can be hydrolyzed to glucose. Similarly, two molecules of glucose are joined by means of glycosidic linkage to form a molecule of maltose. So, in both forms they exist. That is, when two molecules of glucose come close to each other, it results in the formation of a maltose molecule. And this maltose does not occur free in nature, and it is formed by the condensation of two molecules of glucopyranose. And it is not so sweet as sucrose. Lactose. Lactose is a sugar found in milk, and it is formed by the condensation of glucose and galactose. And this, when one molecule of galactose and glucose are joined together by glycosidic bond, it results in the formation of lactose. And the enzyme lactase in human beings are capable of hydrolyzing this lactose into galactose and glucose. Another example of disaccharide is sucrose. They are joined by by a molecule of glucose and fructose by glycosidic linkage. Here the enzyme sucrase are involved in the cleavage of this sucrose into glucose and fructose, and it is found greatest abundance in certain plants such as sugarcane, carrot, and some sweet fruits also, and it is sweet, crystalline, and freely soluble in water. And the last category is polysaccharide. Now, polysaccharides are made up of 10 to many thousands of monosaccharide monomers in their macromolecules, and they are insoluble in nature. They may be of two types, that is homopolysaccharide and heteropolysaccharide. Homopolysaccharide contain the same type of monomers in their molecules. And some examples of homopolysaccharides include starch, cellulose, etc. Heteropolysaccharides are composed of more than one type of monosaccharide. Example, chondroitin sulfate, hyaluronic acid, peptidoglycan, etc. Now, this classification is mainly based on chemical composition of polysaccharide. Another classification of polysaccharide is based upon the function, that is storage polysaccharide and structural polysaccharide. Those polysaccharides which help in storing food materials in plants are known as storage polysaccharides. For example, in case of plants, starch, and in case of animal, it is glycogen. So the main function of storage polysaccharide is that they are helping in storing food materials. And it may be in different forms, that is in plants they are stored in the form of starch, and in animals they are stored in the form of glycogen. Structural polysaccharide, another type. This is helping in maintaining the mechanical shape and rigidity of the living cell in plants. Example, cellulose. So polysaccharide can be divided on the basis of chemical composition as well as based on the function. Now some of the examples of this polysaccharides. First one is starch. Starch is a homopolysaccharide. It is a complex substance formed by the condensation of amylose and amylopectin. Then it is linear polymer with high molecular weight in the range of 1,50,000 to 6 lakh Dalton. Amylose is formed in plant cell by the elimination of a water molecule. Then the linkage in amylose is an alpha-1,4-glycoside as in case of maltose. And the enzymatic hydrolysis of amylose with amylase yield maltose unit. Whereas amylopectin process nearly 300 to 5500 glucose unit per molecule. And it has the same basic chain of alpha-1,4-glycoside linkage as in amylose. But it has an addition, in addition to this, it has many side chain attached to the basic chain by alpha-1,6-glycoside linkage. So the slide shows the structure, chemical structure of amylose. It contains repeated monomeric unit of glucose. So amylose and amylopectin. Next comes the cellulose. Cellulose is a fibrous water-insoluble substances and they are found in the protective cell wall of plants. It is a linear unbranched homopolysaccharide. And here the glucose units are connected by means of beta-1,4-glycosidic bonds. And it is widely distributed in nature. And the slide shows the chemical structure of cellulose. And they are joined, they contain repeated monomeric unit, that is glucose linked by beta-1,4-glycosidic bonds. Another example is chitin, which is found in fungi and is the principal component of arthropods and lower animal exoskeleton. It is a linear polymer of beta-1,4 linked N-acetyl glucosamine and it is acted upon by the enzyme chitinase. And this is the structure of the chitin. And here it is a linear polymer of beta-1,4 linked N-acetyl glucosamine. It may be regarded as a derivative of cellulose in which the hydroxyl group of the second carbon of each glucose unit have been replaced by acetamido group. So this is about carbohydrate. And regarding the heteropolysaccharide, they are polysaccharides which on hydrolysis is mixture of monosaccharide. So here different types of monosaccharides will be there. Example, peptidoglycan. And this peptidoglycan are most commonly seen in bacterial cell wall and they are made up of alternating beta-1,4 linked N-acetyl glucosamine and N-acetyl muramic acid residue. Another example is hyaluronic acid and it is abundant member of polysaccharide found in higher animals and they are the important components of various tissues such as umbilical cord. And it contains a straight chain polymer of glucuronic acid and N-acetyl glucosamine alternating in the chain. So these are different types of carbohydrate. Carbohydrates are the compounds of carbon, hydrogen and oxygen and are major source of energy in the body. And they are classified into monosaccharide, disaccharide and polysaccharide. Monosaccharide are the simplest carbohydrate.